for the mean. The objective of this presentation is to determine the appropriate method in comparing means, to be able to interpret graphical outputs. So we have mean differences between groups. So we have 3 groups here. If you notice, the groups are well separated and there is no overlap between members. One may assume that the means are different among the 3 groups. Okay, so here you have more or less, so you have here the mean for the first group, you have the second group, and the third group. So we would see that the mean of group B is greater than the mean of group C and A. In this particular graph, so you would see that more or less, the 3 samples here have the same mean. They are actually being separated, but basically meaning that the groups are identical, but almost identical. But yeah, basically the if you try to look at the box plots, more or less are the same. Okay, so this one, there are overlaps among the 3 groups, but the sample means are different. So this is the mean, more or less, of the first group, the mean, but the means are closer, compared to the first example. You can see that there is you would expect that the means of the 3 are significantly different. Here, more or less, this is the same. However, this one is with the means are different, although they are close, but the purpose of mean comparison or comparison of means, it's for us to determine even if the mean, for example, is close, their means are close, perhaps still we can consider that the groups involved are different. So we can do that using the Ttest, or if there are more than 2 groups, then we have to use analysis of variance. So what are we going to do? So this is activity 2.4. So click analyze, explore, so we can have we can use the WWRs and TVRs in the dependent list. It means that this is the main variable of the study, while the factor or the independent variable, you have sex, and then we would like to see the stem and lip display, and perhaps we can compare the results, of the two variables. So the grouping variable here, or the factor, is sex. Okay, so if we are going to use our GSS 2002 data set, so you have analyze, descriptive, and then explore. So we have to reset, and then again right click. So the dependent list is, again, that was WWR and TVRs, TVRs, this one. And then the factor is sex. And then plot stem and lip display by default actually. And then continue, and then okay. So we have here the results, no, for the males, no, and the females, their the variable hours per week, no, in the internet. So you have, yeah, basically it's what, it's still skewed, no, the PVRs times 0.2, of course this will result to a decimal, no? And then yeah, for what, this one, yeah, skewed because it's 1 point. For the stem and lip display, we can see that it is somewhat skewed to the right. And then of course there are outliers, no, based on the box plot. You notice that the performance of, if you try to compare the mean for the males and females, no, for the number of hours spent in the internet, the males are a bit higher, no, compared to the female. For TVRs, more or less the same, no? Okay. That's it, no? If you want to have an idea of the data set that you are trying to analyze. So you have here the Ttest. Okay. Excuse me. Perhaps I will transfer to the Word file, although we will be following the activities here, just to have a clearer picture of the different tests of difference. So the T-test is commonly used to obtain a probability statement about differences in means between two populations. That is, if you are using the if you have two groups, no, if you will compare the two, whether there is a significant difference between the means of two independent samples. But there are different types of t-tests. So I believe, I do not know if you have a copy of this it's actually Word file, and I use this in my class, no, to discuss the different tests concerning means. Okay, so we have first the one sample t-test. So this is a test which is if you want, so this is a statistical tool, no, that is used if you want to test whether there is a significant mean difference between the hypothesized value and the actual value or the observed value of one sample group. So there is only one group, no, which is our of interest. Now, like for example, if you are talking about let's say the students of Mariano Marcos State University, so that would be your target population, no? So perhaps you take a sample of college students of MMSU, no, and then you make a hypothesis about some scaled variables. Okay, so basically, no, so we follow the steps in hypothesis testing. In most books, there are 7, some books 9, some books there are 5. But usually, since you are using the software IBM SPSS, and I reduce it only to 3 steps. No, the first step is you have to state the null and the alternative hypothesis. The second step is to state the level of significance, and then the third step is you provide the table, and from the table, now you try to make decisions and conclusions. No, so let us use the data here, the data mining data set. So data mining. So one of the variables that um, we have in data mining now is the prelim exam scores. So the prelim exam scores. So you have here the prelim exam scores. Okay, so you notice, no, it's a value between 50 and 100. Okay, so you have only one sample, and you would like to know, you would like to check whether the average prelim exam scores of the students is 75. Okay, so your null hypothesis, the average prelim exam scores of the student is 75. That is, the average is equal to 75, no? So if we try to express our null hypothesis in terms of, uh, actually, it should be in terms of the population mean, no? Which is 75. And then let us have alternative is not equal to 75. So take note that we are using here a non-directional, no? So a two-tailed test actually. Okay, so step number 2, as usual, no? So we use alpha, the level of significance is 0.05, and then step number 3, we provide SPSS output and formulate conclusions as well as possible implications. So if we try to make the analysis here, so analyze, compare means. So you have here one sample t-test, you have independent sample. So one sample t-test, that is if you have only one group, this is what we are discussing right now. The independent sample t-test, if you have two independent groups, no, like for example, if you want to compare the mean score of MMSU, Don Mariano Marcos State University, and perhaps against Don Mariano Marcos State University, so you will be using independent sample t-test. Or perhaps you would like to compare the mean scores of the students taking up engineering and taking up IT or computer science, no? So you have two groups, the engineering and the IT or the CS group. Okay, for the paired t-test, there is only one group, but you take two observations, usually before and after. For analysis of variance, one-way analysis of variance if there are more than two groups. No? So for the purposes of this training, we will be discussing only the one sample t-test, independent sample t-test, the paired, and the one-way analysis of variance. One-way analysis of variance, or you call it actually as one-factor analysis of variance, it means that there is only one independent variable. For a two-way analysis of variance, there are two independent variables, and for a three-way or three-factor analysis of variance, there are three independent variables. And you also have basically this is test concerning proportions. That is, if your data are proportions, no, or percentages. If your data are means, then you have to use the t-test or analysis of variance. So based on we will be using the prelim exam scores, no? So what we do, we click analyze, compare means, and we use the one sample t-test. Okay, so the prelim exam. And you notice in our null hypothesis, so this is actually your hypothesized average for the population of interest, no? So you can change this to, it depends upon you. It can change it to 75 or 80 or 90. It depends, no? So in here, we specify that the average is 75 because it is a requirement when you perform one sample t-test. What is the test value? The test value is the hypothesized value, which is 75. We just uncheck estimate effect sizes. And then, okay. So what we are testing actually here is, okay, so we have here the result, no? You have, there are 147 students and the mean of the prelim exam is 84 more or less, no? The standard deviation, and then you have the standard error of the mean. And then take note that the test value is 75 as we have specified in our hypothesis, no? So actually, we will be testing whether 83 or 84 is different from 75, no? So that is what we are doing here in one sample t-test. So we have, okay, so take note that you have here the significance. So it's up to you, no? It depends upon your alternative hypothesis whether it is one-tailed or two-tailed, no? Although the values are just the same, but there are instances that these two are different, no? Because for the two-tailed, if it is two-tailed, then you have to divide this by 2, no? Okay, so you have, since our alternative hypothesis is not equal, it means that we will focus on the output for the two-tailed. Okay, so it means to say that the students, the prelim exam, the average is 80, more or less is 84, no? And then based on the results, since the p-value here is less than 0.05, it means that there is a significant difference between 75 and 84, meaning we are going to, so we have here the output, no? So you have, since the p-value is 0.000, which is less than 0.05, or you may copy the one that you get here, meaning less than 0.001, meaning smaller than 0.001. We have less than 0.05, then we have to reject our null hypothesis. So if we reject this, no, the null hypothesis, therefore our conclusion would be the alternative hypothesis, no? It means that the average prelim exam scores of the student is not 75. In fact, it is 84, which is greater than 75. You understand? Okay, let us have another example. This time, we will hypothesize that it's 85. Okay, so in the first case, we have hypothesized that it's 75. Now, let us see if what would be the result if we'll change this to 85, no? So it's just the same except that we change 75 to 85. So we have the same null and alternative hypothesis. Still, the level of significance is 0.05. And obviously, our result would be the same. I'm sorry. No, not the same, but of course, we have to change the sorry, one sample t-test. So we change this to 85. And then, okay. Okay, so you would notice that the p-value here is already, since our alternative is not equal, so we'll focus on the two-sided p-value. So take note that this is already changed, no, from 75 to 85. And then the result of the t-test gives us a p-value of 0.191, which is greater than 0.05. So actually, we are going to compare whether 84 and 85 are statistically significantly different, no? But since this is greater than 0.05, we will have to accept or fail to reject our hypothesis, no? So since 0.191, which is greater than 0.05, we will accept HO. So if you are going to accept HO, it means that this is your conclusion, no? That the average prelim exam scores of the students is 85. It means that it means that there is no significant difference between 84 and 85. Actually, is 85 is more or less the same as 84, or 84 is the same as 85. What is the difference between the two? Actually, if you try to look at the one sample t-test result, the difference between the actual mean, this is the actual mean, and the hypothesized mean is negative 1.1, no? So it means that 1.1 is not enough to conclude that 85 is greater than 84. So it means that more or less 84 is just the same as 85. So that is why we have accepted the hypothesis. So if you accept the hypothesis, you are saying that there is no significant difference, no, or no significant effect or impact, no. So here you notice that we have the test value is 75 and the actual or the observed value is 84. In this case, we have rejected the null hypothesis because no, we cannot say that 75 is more or less the same as 84. There is a big difference between 84 and 75. And what is the difference? That is more or less approximately equal to 9. And 9 is significant, no, to conclude that 75 and 84 are different. That is for the one sample t-test. We have only one group, and then we take the mean of the group, and then we will compare it with a standard, no, or whatever is the hypothesized value. Okay, so for example, if we test the midterm exam scores of the students 78, no, and then alternative this time is less than, and alpha is 0.05. So if we use our IBM SPSS, so what is the variable again? That is midterm exam, and then 78. So analyze, compare means, one sample t-test, you have midterm exam, and then we change this to 78, and then okay. So you would see here that, okay, the p-value, we are going to use the one-sided, no, because we have specified in our alternative hypothesis is less than 78. So we will focus on the one-tailed, no, which is 0.006, and 0.006 is actually less than 0.05. Actually, you have to divide this by 2, no? You have to divide this by 2 because this is two-tailed. So we have to divide this by 2, and more or less that is equal to 0.006, no? Is less than 0.05, so therefore we will reject HO. And the average midterm exam scores of the student is what? Less than 78. It means that there is a difference between 75 and 78. You cannot say, although 78 and 75 are close, no, but the 3 points difference is significant. When you say that the 3 points is significant, it means that it matters. No, it means that 75 is not the same as 78. You understand? Okay, we will proceed to, I will give the exercise no, after we discuss all t-tests and analysis of variance. Now, the independent sample t-test, or you call this as the uncorrelated samples, this is already when there are two groups. So as I have said, if we will compare, for example, performance in the board exam of graduates of Don Mariano Don Mariano Marcos State University and another, perhaps a neighboring university in Ilocos Norte, no, private school. You compare, for example, their performance in their scores in the let's say CPA board exam or whatever as board exam, or in the program are both offered to the two schools, no? Or you can compare male versus female, or you can compare BS Accountancy and BSBA graduates or students. So you have two independent groups. So the same procedure, but this time you have already two groups, no? So state the null and the alternative hypothesis, and then you have to specify the level of significance, and then you have to uh, output, no? Provide the output of IBM SPSS. So you have here, so your independent or your factor here is the sex of students, no? And then you will be comparing the performance of the males and the females. No? So if we do it using IBM SPSS, so choose, analyze, compare means independent sample t-test. So your test variable, that is your dependent variable, and that is the prelim exam. And then the the grouping variable would be the sex, no, of the students. Okay, and then you have to define groups. I think let me just check. Cancel. Let me just check with what is the, okay. So sex is actually 1 for male and 2 for female. So, or you can have 0 for male, 1 for female. But what we have here in the values, 1 is assigned to males and 2 for females. Okay, so analyze. Compare means independent sample t-test. Now the test variable again is the prelim exam, and then we will compare the male and the female. So take note that you notice when I click sex, now you have under grouping variable, you have question marks there, no, for the sex. It means that you have to define the groups, no? Depends upon what codes did you use, no? So define groups, so it's okay 1 and 2, no? And then continue, and then just uncheck this, and then okay. So you have the result. For the prelim exam, there are 92 males, you have 55 females, and then you have their means in the prelim exam, and then the standard deviation. Okay. So, what is our alternative hypothesis here? No. So, two-tailed, no? Okay, so you have, okay. The first thing that you have to do, so actually the main significance that we have to consider is the one that is with label above the one-sided or the two-sided, no? And then there are two values, no? Above and below. So which one are we going to choose? Okay. So based on the output, no, for the t-test, it first determine whether the variances of the population of interest, no, are assumed to be equal or assumed not equal. Okay. So because there are two formulas for the t-test, no? So one is you use the formula if the variances are assumed to be equal, while the other one is assumed not equal. So you have to look at the sig here. This is actually the Levens test for equality of variance. Since this is greater than 0.05, it means that the variances are assumed to be equal because the null hypothesis here, the variances are equal and the alternative are not equal. Since the p-value here is greater than 0.05, so not significant, meaning the variances are assumed to be equal, you will have to look at the value above. Since we are using the two-sided, the not equal, no? So we will use the 0.118. Let's just double check. Yeah, not equal. So we are going to use the 0.118. Okay, so again, however, if this is, for example, less than 0.05, you will consider the value below. Okay, so I will copy paste this to Word, no? So you have already the table, the output, okay. So 0.118, and since the p-value are the sig 0.118 is greater than 0.05, this means that we will accept HO, meaning not significant, no? We accept HO, it means that there is no significant difference between the prelim exam scores of the male and the female students. Okay? And it means that here, if you try to look at the mean score of the males, it's more or less 85, and the female got an average of 82. Numerically, the male group scored higher by 3 points, no? Compared to the males, I mean the females, no? But the 3 points is not enough to conclude that the male population is or has a higher performance compared to, or a greater performance compared to the female population, meaning the 3 points is not significant. You understand? Okay. And then the next is you have perhaps another example. So the midterm exam. So no significant difference in the midterm exam performance between the male and the female. Okay. There is a significance alpha. This is the output. The score of the males 76, the female is 74, a difference of 2 points. And then since the sig here is 0.801, which is greater than so we'll consider the value above. And since 0.445 is greater than, we will accept HO, no significant difference. The Ulraman, I mean, they're close, no? Their means are close. we will consider, for example, the midterm quizzes. In our data set, we have midterm quizzes. This one. Okay, analyze, compare means, and then independent sample t-test, midterm quizzes. Then same grouping, no? So we can just click OK. So the mean of the males, 69. The females, 85. So na difference na 4 points, no? And then if you try to consider, okay, here, now, the sig here is 0.02. And this is less than 0.05. It means that the variances are not equal. So it means that you have to consider the one below. But since we are using the two-tailed, we'll consider 0.0031. Okay? So this is less than 0.05. This means that we will reject h sub 0. There is a significant difference in the midterm quizzes performance between the male and the female students. In fact, you can conclude the male students perform better. Kay higher man ang ilahang, sorry. Sometimes I forgot that So there is a significant difference, no? It means that the 5 points difference is significant. It matters. No? So therefore you can conclude that the male group perform better compared to the female group in the midterm quizzes. This is another example. Okay, perhaps I will ask you to do this. You have to, okay. Okay, I have to get to demo this to you, no? Perhaps not everyone knows how this is encoded, no? It's okay because the files that we provided to you are already encoded properly, no? So it is with the assumption that you know how to encode data in SPSS, no? Okay, so I have here yields, no, potato yields, no, and then the yield here is the dependent variable and the fertilizer is the independent or the factor. And then you are to test whether there is a significant difference in the yields between in the use of fertilizer X and fertilizer Y. So you have the yields here of fertilizer X as well as the yields of using fertilizer Y. So if I'll open a blank IBM SPSS data, new data. So you have the variables, no? So your dependent would be the yield, no? The yield. And then the second variable is the factor, which is the fertilizer. Fertilizer. And then perhaps the label is potato yield. And then fertilizer is the type of fertilizer. And we have to define the type of fertilizer. You have, let's say, one is fertilizer X. Add, and then two, fertilizer Y. and then add, and then okay. So how many data points we have? How many observations? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 for fertilizer X and 9 for fertilizer Y. So we must have, in our data set, we must have, so if you go to data view, under fertilizer, you have, there will be 9 ones for fertilizer X and 9 fertilizer Y. Okay? And then you have to write the values of for the yield, no? You have for the yield 18, 21. Let me write it first. You have 21, 18, 14, 20, 11, 19, 8, 12, 13. You have 12, 14, 10, 8, 16, 5, 3, 9, and 11. Okay, so I will encode this, the data, the dependent variable. You have 21, 18, 14, 20, 11, 19. I hope everyone is also encoding this 8, 12, and 13. And then you have 12, 14, 10, 8, 16, 5, 3, 9, and 11. Okay. That is how the data are encoded, no? For when you perform independent t-test. And then now you can start analyzing. So compare means independent sample t-test. The test variable is the fertilizer yield, and then the the potato yield, and then the fertilizer type, that would be your grouping variable. So you have the grouping is 1 and 2. And then continue. And then, okay. So you would see here that the yield of using fertilizer X is 15. For fertilizer Y is more or less 9.7 or 10. No? And then if you check the result for the t-test, the p-value here for the test, for the Levens test of equality of variances is greater than 0.05, meaning we will have to consider the value above, although it's just the same as the one below. So you have 0.019, and this is what? Less than 0.05, which means that we will have to reject the null hypothesis, and we conclude that there are more yields, no, in using fertilizer X. Yields are better using fertilizer X. So there is a significant difference. It means that fertilizer X is more effective than fertilizer Y, no? As shown by their yields. I mean, the number of yields. Okay, and then this one. And then the last for the t-test is the the dependent or the correlated or the paired sample t-test. As I have mentioned earlier, that this is a statistical tool if you want to test whether there is a significant mean difference for data such as pre-test and post-test, before and after, and the like, no? So you have, for example, if you want to know whether physical exercise, if you go to the gym, it is effective in reducing weights. Now, first you have to get the weights of the respondents before they will go to to the gym, no? And then perhaps after 1 month, you measure their weights again. You try to check whether there is an improvement in their weights. So I mean, a similar example is you have here a study about the effect of after 6 diet on weight reduction. Now there were 15, I mean 1, 2, 16 participants in this study, and prior to engaging in after 6 diet, their weights are measured, and then after 1 month, their weights again are measured. So you will have here the weights after. So basically, of course, perhaps I have also again to demo to you know how to encode this. You basically have to encode it as it is no in IBM SPSS. So you will have, I will open another data set and then new data. You have the variable view. So you can have weight before and then weight after. Okay? So all you have to do, you encode the weights before and the weights after. Okay. So the weights before and weights after, and then after that, you will have to choose compare means the paired sample t-test. So for the paired sample t-test, you can drag this one by one, variable 1 and one variable 2. Or you can just highlight the 2 and then use the arrow going to the right. And then just click OK. Uncheck estimate effect sizes, no? And then yeah, and then check OK. And then let us check your result, no? So this is an activity I would like you to share. The first one perhaps to do. So you will have to write down the weights here before and the weights after. You have to encode, no? So this is the data, no? The weights before and after. Let me check if you have here. So the null hypothesis is the weight before is equal to the weight after. It means that the diet is not effective in reducing weights. And then the weight before is not equal to the weight after, or the diet is effective in reducing weights. Then step 2. I need volunteer for this. The first one to produce the result will have a prize from Strand. I think Miss Ma'am Nora had given you the copy of the file, no? I muted. Sir Lee? Sir Lee Zimmer, can you please share your work?
Hello, sir. Good afternoon.
Sorry, Miss. Sorry. Miss Lee?
It's okay po.
Yes. Please share po. Okay. So, fine.
So for the result of the mean or the descriptive area, the mean weight before is 182.25 compared to the mean weight after, which is 177.93. And if we are to test, so for the diet, if it is effective, we want that the mean weight after is less than the mean weight before.
Correct. Very good.
And then on the correlation part, sir, the relationship of the weight before and after is 0.98. So it is highly correlated.
Okay.
And then on the Ttest results, we are going to use the one-sided mean because there is a direction, sir.
That is if your alternative is you specified in your alternative that the weight the after 6 diet is effective. So in this case, failed, the one-sided. Correct. So you have that is 0.00, which is less than less than 0.05, no? Which means that Miss Lee
Yes, sir.
means that the p-value is 0.002, which is less than 0.05. It will lead to the
There
rejection
is
of,
a significant difference.
yeah, there's a significant difference. In fact, it is effective, no? The weights are reduced by an average of, what's that? By about 5 or 4 points, no?
Yes, sir.
Oh, this implies, thank you, Miss Lee. Thank you so much. Oh, Nor,
Yes, sir.
another house and for,
Yes, sir. Noted po na na ah, sulat ko na po.
okay, thank you, Nor.
Thank you.
Okay, so we continue. Share screen. Okay, that's it for the Ttest, no? So the last one is about the analysis of variance. So analysis of variance, or ANOVA, is a statistical tool used to compare means of 3 or more groups. So if there are already more than 2 groups, so you will have to use ANOVA, no? And there are 3 types of ANOVA. You have the one-way. It means that there is only one independent variable. The two-way, if there are 2 independent variables, and the three-way if there are 3 independent variables. Actually, for one-way analysis of variance, you will be testing only one hypothesis. For the two-way, you will be testing 3 hypotheses, while for the three-way, you will be testing 6 or 7 alternate null hypotheses. Now, for this course, we will only talk about the one-way or the one-factor analysis of variance. So the one-way ANOVA is used to test whether there are significant differences among 3 or more groups, no, according to a certain parameter. So if we are going to use our data mining scores and we use the prelim exams, and then our independent variable is the sections, no? So actually in our data set we have 3 sections, no? We have section A, B, and C, no? So we have here encoded it as section 1, no? So you have there, if you double check on the variable view, so under section, you have 1 is for section A, 2, section B, 3, section C. Okay. So I'd like you to take note that if, for example, your groupings are with A, meaning purely nominal, meaning you have encoded it as string variable, no? In order for you to run analysis of variance, this has to be transformed to numeric variables. Bali, numeric siya, but still nominal. Nominal. So while there is no, it's not string, no? Because there is no A. Because if you will notice later on, you cannot see this in the choices if you have a string for your grouping variable. Okay, so what we have here is, so there are no significant differences in the prelim exam performance of the students when they are grouped according to their sections. So mean of 1 is equal to mean of 2, mean of 3, meaning the mean of section A, section B, and section C are equal. But for the alternative hypothesis, there are significant differences. And the alternative, and the step 2 is you have to specify the level of significance alpha 0.05, and then you have to provide statistics and ANOVA table and then the interpretation. Okay. This is what are you going to do first, no? When you do analysis of variance, so you go to analyze, compare means, the one-way ANOVA. Okay, so our dependent is the prelim exam. And then our factor or our independent variable is section 1. So you notice this is what I'm telling you a while ago, that the section with or in there is an A, so it means it is string. You cannot see it here. So that's why it's very important that you know that you have encoded your data properly. Okay, so the section would be our factor. And then what are you going to do first is you click OK. Do not touch yet, no? These choices here. So OK. Okay, you have the result. Yeah, this is the result. You notice, no? So you have the output of the ANOVA. You have to check first the p-value, no? That is 0.04, and that is less than 0.05. It means that there are significant differences in the average prelim exam scores of the students coming from the different sections. If, for example, this is greater than 0.05, you can just stop there and perhaps you can just present the means, no, the descriptives. Okay. So since this is significant, so you run it again, and then compare means, analysis of variance. So the options, you click on descriptives, you click on the plots, the means plot, and then continue. And then because we will be comparing here section A versus section B, A versus section C, and B versus section C, no? Because if only one of these is significantly different, ANOVA will declare that the significant is, the results is significant. So we have to do post hoc to determine which pairs are significantly different. So post hoc, actually there are many that you can choose here. This is just a statistical test, no? For one to determine which pairs are significantly different. So in my case, I employ Tukey, because Tukey